topic is the relation between frequency time and frequency response. Time. Introduction. Time domain analysis, frequency domain analysis. Example: voltage measurement from a solar panel. Summary reference. Consider a two-part model of linear time variant system shown in figure. A signal x of t is applied to the input and the response y of t is observed output. The response is obtained as the convolution of the input. The system impulse response h of t and the system response is h of t. Impulse response is h of t. We given the signal x of t as a input and we got response of y of t, where h of t is the system impulse response. Y of t equal to x of t, here star marks called as a convolution of h of t, that equal to integration of minus infinity to infinity x of t into h of t minus tau dt. Introduction and measurement system. It is required to develop mathematical tool that will allows us to quantitatively analyze measurement system, true value, sensing element and sensing signal condition element, signal processing element, data presentation element, measured value. Introduction. Two types of mathematical tools: time domain analysis, frequency domain analysis. Time domain analysis examines the amplitude vs time characteristics of measuring signal. Frequency domain analysis replaces the measured signal with a group of sinusoidal which, when added together, produce a waveform equivalent to the original. The relative amplitude, frequency and phases of the sinusoidal are examined. Time domain analysis. In time domain analysis, the response of dynamic system to an input is expressed as function of time c of t. It is possible to compute the time response of a system if the nature of the input and the mathematical model of the system are known. The time response of a system can be obtained by solving the differential equation governing the system. Alternatively, the response of c of t can be obtained from the transfer function of the system and the input of the system. For a closed transfer function, c of s by r of s equal to g of s by 1 plus g of s h of s. Transfer function of closed loop. Response in S domain is c of s equal to r of s into m of s. Response in time domain, c of t inverse of Laplace c of s. Time domain specification. For a specifying the desired performance characteristics of a measurement control system, the characteristics of a system of any order may be specified in terms of transient response to a unit step input signal. The response of second order system input is c of s by r of s equal to wn square by s square plus 2z wns plus wn square w square n. Time domain specification. Delay time, peak time, settling time, rise time, peak overshoot, steady state error. Here given the diagram. Time domain specification. Delay time. It is the time required for a response to reach 50% of the final value in first attempt. Rise time. It is the time required to rise from 0 to 100% of the final value for the underdamped system. Peak time. It is the time required for the response to reach the peak of the time response or the peak Peak overshoot, settling time. It is the time required for response to reach and stay within a specific tolerance band 2% or 5% of its final value. Peak overshoot. It is the normalized difference between time response peak and the study output, and it's defined as percent of m of s equal to c of tp by minus c of infinity by c of infinity into 100%. Steady state error. It indicates the error between the actual output and the desired output as t ends to infinity. Frequency domain. Introduction. Advantages. Stability of closed loop system can be established. Transfer function of complicated system can be determined experimentally by frequency test. Effect of noise, disturbance and parameter verification are relatively easy to visualize. Analysis can be extended to certain nonlinear control system. Frequency domain analysis. Frequency domain specification. Resonant peak frequency, resonant frequency, bandwidth, cutoff rate, gain margin, phase margin. Frequency domain analysis. Frequency domain specification. Resonant peak, maximum value of the closed loop transfer function. Resonant frequency, frequency at which resonant peak occurs. Bandwidth, range of frequency for which the system normalized gain is more than minus 3 dB. Cutoff rate, it is the slope of the log magnitude curve near the cutoff frequency. Gain margin, the value of gain margin is to be added to the system in order to bring the system to the average of instability. Phase margin, additional phase log to be added to the gain crossover frequency in order to bring the system to the average of instability. Frequency domain analysis. Frequency response plots. Frequency domain analysis of the system can be carried either analytically or graphically. There are various graphical plot techniques: Baud plot, polar plot, Nicholas plot, M and N circle. Frequency response plots are used to determine the frequency domain specification to study the stability of system. Here the frequency domain analysis are resonant peak, resonant frequency, bandwidth, cutoff rate, gain margin, phase margin. Whereas time domain specification: delay time, rise time, peak time, settling time, peak overshoot, steady state error. Delay time, it is the time required for the response to reach 50% of the final value in the first attempt. Rise time, it is the required time to raise from 0 to 100% of the final value for the underdamped system. Peak time, it is the time required for the response to reach the peak of time response or peak of overshoot settling time. It is the time required for the response to reach and stay within a specific tolerance band 2% or 5% of its final value. Peak overshoot, it is the normalized difference between the time response peak and the study output is defined as study error. It indicates the error between the actual output and desired output as t tends infinity. These are time domain specification. Frequency domain analysis are resonant peak, maximum value of the closed loop transfer function, resonant frequency, frequency at which resonant peak occur, bandwidth, range of frequency for which the system normalized gain is more than 3 dB, cutoff rate, it is the slope of the log magnitude curve near the cutoff frequency, gain margin, the value of gain is to be added to system in order to bring the system to the average of instability. Phase margin, additional phase lag to be added at the gain crossover frequency in order to bring the system to the where of instability. Thank you.